Moving on to alkenes, we know that alkenes are hydrocarbons that consist of at least one carbon-to-carbon double bond. So I've shown you two quite simple alkenes here. This one is called ethene or ethene because it's made up of just two carbon atoms, and this actually is the simplest alkene. The next one is propene, which contains three carbon atoms in the longest chain, and again only has one carbon-to-carbon double bond. This just summarizes a little bit about alkenes at first. So knowing they contain at least one carbon-to-carbon double bond, we classify them as unsaturated compounds because they don't have the maximum number of carbon-to-carbon single bonds as well as carbon-to-hydrogen bonds. The following notes here help explain how we actually determine the name of these alkenes because there's a little bit more to it. Firstly, the double bond must be included in the longest carbon chain. So regardless of whether that is the longest carbon chain or not, the double bond must be included. The second note is that the double bond is assigned the lowest possible number when we name, and we represent this in the systematic name. So at this point we actually ignore the any alkyl groups that may be positioned and trying to assign them the lowest possible number. We essentially say that the double bond takes precedence over any of those alkyl groups. It's the more important group of the molecule because it gives rise to its different chemical properties. Our first example is looking at this particular alkene, which we need to know how to name. The rules are very similar to the rules for naming alkanes. The first step is to determine the number of carbons in the longest chain. We've got 1, 2, 3, 4, 5, 6 carbons in the longest chain. So its parent name will start with hex, but it's an alkene, so it's called a hexene. What we can do is then number the carbon atoms. What we see is that this carbon-to-carbon double bond actually exists between carbons 3 and 4. So we just take the lowest number carbon that it's bonded to, and that helps us indicate what type of hexene it is. So we say it's a 3-hexene. An alternative way of actually writing this is to put the 3 in between the hex and the ene. And so this would be pronounced as hex 3-ene. Either of these names are actually deemed correct. So it's important to be familiar with both of these representations because you might be expected to know how to draw from both of these names. Example number 2. So now we're starting to introduce some alkyl groups. We've got 4 carbon atoms in the longest chain. So it's going to be a bute. Because it's got a double bond, it's going to be an alkene. So we've got a butene. This CH3 group is going to be a methyl group, and we want to number the carbons so that this double bond has the lowest possible number. So we need to number from left to right. The double bond is positioned between carbons 1 and 2. So before we actually name the parent chain, we identify the alkyl groups and name that first. So we've got a methyl group on carbon 2. So it's 2-methyl. And it's going to be a butene, but it's going to be positioned on carbon 1. So it's called a but-1-ene, or alternatively we can call it a 2-methyl 1-butene. Again, both are accepted as correct answers. Another example here. So again, I've just changed this slightly. Remember that we want to determine the longest chain of carbon atoms. So in actual fact, we've got 5 carbon atoms in the longest chain. So this is going to be a pentene, and we've got this double bond here positioned between carbons 2 and 3. So we're going to call this a 2-pentene, or pentene is the other accepted name for it. You can see in this point I didn't actually number the carbon atoms because I felt like it wasn't necessary. Example 4, Again, something quite similar. The longest carbon chain is still 4 in this case, so it's going to be a butene. We've got methyl groups down here and up here as well. 2 methyl groups, so it's going to be called a dimethyl. And in this case, it doesn't actually matter which way I number this. So I'll just number it from left to right. And you can confirm this if you want to number it from right to left, that the names are actually going to be the same. But let's name the alkyl groups first. We've got 2 methyl groups, 1 on carbon 2, 1 on carbon 3. It's going to be a dimethyl. 4 carbon atoms, so it's a butene. The carbon to carbon double bonds position between carbons 2 and 3. So take the smallest number and it's a 2-butene. And I'll write the alternative name underneath. And there we have it. One more added level of complexity is when we have multiple alkene functional groups or multiple carbon to carbon double bonds. And we've seen these prefixes before, so we actually use them to denote when we have multiple alkene functional groups. If we have 2, we're going to call it a diene. 3 is going to be called a triene, and 4 is going to be a tetraene. We place this prefix directly before the ene part of the name itself, as we can see down here. Example 5, we can see that we've got 2 of these alkene functional groups. We can see there are 4 carbon atoms in the longest chain. So this is going to be a butene, but it's going to have 2 alkene functional groups. In this case, we're going to number from left to right. We'll identify our alkyl group as well. So a methyl group on the second carbon there. We'll start off with that group. So we've got a 2-methyl. Because it's got the 2 double bonds, we're going to start off with the fact that it's going to be a bute. The double bonds are positioned on carbons 1 and 2 and 3 and 4. So we're going to use the 1 and the 3 to represent where these double bonds start. So it's a bute 1,3. To just confirm that there are 2 of these groups, we call it a diene. So 2-methyl bute 1,3 diene. If we want to name it the other way, there is just a slight variation to this. So the methyl group's the same. We'll put the numbers before we put the butes and the diene together. So 1, 3. What we don't like to do is to put 2 consonants together. So we end up putting an A in between, and so it becomes butadiene. Even if you didn't have that A, I would still give that as a correct response. But by convention, we normally just like to put an A between 2 consonants so it rolls off the tongue a bit nicer. One more example, so another diene, looking at the longest chain of carbon atoms. So we've got 1, 2, 3, 4, 5, 6. This is going to be a hexene or a hexadiene because there's 2 double bonds. We'll go ahead and number it from left to right. And that's because we want to assign these double bonds with the lowest possible number. So it'll assign this a 1 and a 3. If we were to go the other way around, it'll be 1, 2, 3. So that will be given a 3, and that will be given a 5. We'll go ahead and work out where our alkyl groups are as well. We've got a methyl group here and here. So to name this, we'll start off with the methyl groups. 1 on carbon 2 and 5. So it's 2,5-dimethyl. 6 carbon atoms long, so it's going to be a hex. I'll call it a hexa. We've got the double bonds on carbon 1 as well as carbon 3. So it's hexa 1,3 diene. I'll write the alternative name underneath. And so we have both of the ways we can name this specific alkene. So after watching these videos, hopefully now you feel quite comfortable being able to systematically name or draw for a range of different alkanes and alkenes. Keep in mind that we can extend these rules further to looking at alkynes, so that's something that we might do in class. But for the time being, thanks for watching, and I'll see you guys next time.